In our initial installment, we said that there are conservation laws that drive everything in the universe, and that why things move the way they do are related to the law of conservation of momentum and the law of conservation of energy. Although this is a topic of law of conservation of momentum, it's important in many circles to take a look at what's also going on with some types of energy when we're looking at momentum. So it probably will not surprise you that the law of conservation of energy says that the total energy in the universe remains constant. And if this is our universe, we could break off a piece of it, and that could be our system. So we could rephrase it to also say the total energy in a system remains constant. The thing to keep in mind when it comes to conservation of energy is that whereas the total energy remains constant, there are different types of energy, and energy can transform from one type to another. Now, the formula we could look at for the law of conservation of energy might be like this. The initial energy equals the energy at any instant in time. And for our system, we could have the sum of the initial energies equal to the sum of the energies afterward. Energy types can consist of, let's say take our total energy, could consist of chemical energy, kinetic energy, gravitational potential energy, elastic potential energy, thermal energy, heat. There could be wave energy or energy of vibration. There can be sound energy. And many, many more. So the total may remain constant, but we could have chemical energy becoming kinetic energy. We could have kinetic energy becoming gravitational potential becoming energy of a spring becoming thermal energy as vibrational energy, and vibrational energy could become sound. Now, I just randomly chose the order that I wrote these types of energy. These arrows can be drawn in almost every which way we want them to be drawn. So the rule is that although we could also call this a qualifier if we want, that the total energy remains constant. That is the rule. But there are different types of energy, and the energy could transform from one type to another. This is important because when we are looking at momentum, we often ask, does the kinetic energy remain constant? Now, this doesn't really have much to do with the conservation of energy, because kinetic energy can turn into all other kinds of things. We do not expect kinetic energy to remain constant. It might. So we ask, does it or doesn't it? You will very often see others use the phrase conservation of kinetic energy. This is a mistake to talk about conservation of kinetic energy. There is no law of conservation of kinetic energy. There's no reason to expect that kinetic energy would be conserved. We might expect it not to increase because the energy must have come from somewhere. But using the word conservation with kinetic energy is a mistake. You shouldn't do it. What we want to know is, does the kinetic energy remain constant? Not, is it conserved? It's a mistake to combine those words. So, energy says the total energy in the universe or a system remains constant. Although the total does remain constant because that's the law, it can change from one form to another. We sometimes ask, does the kinetic energy remain constant? Now, I want to jump back to the bigger picture. There is one qualifier about the law of conservation of energy, and that is, it is not true when mass converts to energy or energy converts to mass. Through what some people call the world's most famous equation, delta E equals delta MC squared. Or probably more commonly, if you've seen it, E equals MC squared. Energy can be lost, and in that process transform to mass. Mass can transform into energy. This qualifier is that the law of conservation of energy is not true when energy converts to mass or mass converts to energy, because then we're actually changing it to something else. This occurs during nuclear reactions. So we're talking about inside the nucleus of an atom. Big takeaways, again, total energy, a universe system is constant, except when energy is converting to mass or mass is converting to energy. Energy does remain constant in all the situations we are going to look at in AP Physics 1. But the energy may convert from one type to another. For example, kinetic energy may go into sound energy, it may go into thermal energy, it might go into potential energy, other types of energy. We have no reason to really expect that kinetic energy would stay the same. In fact, we would usually expect it to decrease because some of the energy is converted to other things. But when it comes to conservation momentum, that doesn't happen. There's not different types of linear momentum. There's not different types of linear momentum. The law of conservation momentum is always true.